All right, here we are back again. We are moving into our bone and cartilage section. So this is going to take us chapter 6, chapter 7, chapter 8, and that'll finish us off before exam 1. Um, my thoughts on studying here is I would recommend, since you have your disarticulated skeletons, that you start learning the names of the bones first and start with the big bones. Get confidence in them, move to the smaller bones, then move to the projections and landmarks of bones, and then you can really study up on the details of the bones. But we're going to start with the details and move kind of in the opposite direction so that you have these as you are doing kind of that big, macro to micro studying. So let's start talking about cartilage. Just a quick introduction. The skeletal system is now our second body system that we're studying. The skeletal system is an organ system with tissues that grow and change throughout the life, and it's composed of bones, cartilages, ligaments, and other supportive connective tissues. And really, it's has several purposes. Um, but a quick preview is some words or some word breakdowns that will help you as you begin to study this. Chondro is a prefix that refers to cartilage, whereas osteo is a prefix that refers to bone. You'll also see the suffixi, blast versus site. And so blast, you can think of as the builders. These are immature, highly active cells that actively are secreting that extracellular matrix. Remember the matrix, that extracellular means outside of the cell. The matrix, remember, is kind of a characteristic of connective tissue. And it's what surrounds the cells and kind of provides that structural scaffold, if you will. So think of bones as that, or the blasts as what is doing the building. They're in the construction zone. Whereas sites, the word site means cell. These are the caretakers. These are mature cells that have become entrapped inside the matrix that they built. Their activity slows down. They shift more into maintenance mode to preserve the surrounding tissue. So you're going to see these prefixes and suffixes put together and just know what those mean when you see them. So let's first start talking about cartilage. Cartilage is a semi-rigid connective tissue. Think like the flexibility of your ears, the tip of your nose, in between your bones. If you've ever eaten, if you eat meat, you eat like chicken and you get onto the end of the bone, that kind of rubbery area at the ends of the bones, those are all cartilage. It's weaker than bone, but it's also more flexible and resilient. Mature cartilage is avascular. Remember, A means without, so that is without blood flow. It's avascular. Cells in the cartilage, they are chondroblasts, right? Remember, these are the cells that are building the matrix of the cartilage. And then you have your chondrocytes. These are the cartilage cells that are surrounded by a matrix, and they occupy the small spaces called lacunae. Lacuna would be the singular of that. So we talk about distribution in the body. You can see that we have cartilage in our ears, cartilage in our shoulders. This word articular, that means connection. Like that's where two bones meet is an articulation. So you have a disarticulated skeleton in a box at home. Articular cartilage happens between those connections. Your vertebral discs, in between all of your vertebral bones, is cartilage in an intervertebral disc. You also have articular cartilage in your knee. You have this meniscus. Mine has been torn and repaired and cut out, leading to now no cushion in one of my knees. And so that is that's going to lead to some arthritis later on in my life, unfortunately. Um, and then you also have this elastic cartilage, like we saw up here in the tips of the nose or in the ears, elastic because it can bend, right? You can also see that kind of in the epiglottis and your trachea. You have cartilages holding these things up. So three different types of cartilage, right? You have the hyaline cartilage with kind of a larger extracellular matrix. You find this in around the trachea. Fibrocartilage, you can see in here some lacunae with chondrocytes, and you have more of those collagen fibers in there, providing that flexibility and strength. And then the elastic cartilage, where you have more of these elastic fibers, providing more of that flexibility. Functions of the cartilage. Cartilage has three major functions. Supports soft tissues, muscles, and such. Some examples are in the airway and the respiratory system, the auricular of the ear, right? We talked about that. Providing gliding surface. So those are those articulations, joints where two bones come together and they glide together. We don't want just bone on bone, but we want that soft cartilage allowing for that gliding to happen. And then they model for bone formation. Begins in the embryo, cartilage grows, and then it is eventually replaced by bones. If you've ever held a very newborn baby, you might know that there are some areas that are should be hard but are actually flexible, and that's where that cartilage still hasn't been fully replaced by bone, and that's why babies' bones can grow so fast. Two types of growth in the cartilage. We have interstitial growth. Inter means between, and so this is growth that happens within the cartilage, and then appositional growth. This happens along the periphery or the superficial layers of the cartilage. You see here, we have interstitial growth. It involves four major steps. First, we have mitosis happening in those chondrocytes in the lacunae. Mitosis, remember, you're getting two identical daughter cells. They form two chondroblasts per lacuna. So a chondroblast, remember, that's the building of the cartilage. And then each of those chondroblasts synthesizes and secretes new matrix, whether it be collagen or elastin, and this separates the cells, which are then, once they're separated, they're in their own lacuna, and they develop into chondrocytes, mature cartilage cells. And they continue to grow as new matrix is produced from within, the interstitial growth. Results in larger pieces of cartilage, and the newest cartilage is on the inside or deep within there. Now, appositional growth involves three major steps as well. You have mitosis of stem cells deep in the perichondrium. So stem cells, remember, these are cells that have not really decided yet what kind of cells they're going to be. And they divide, and some of those stem cells become chondroblasts at the periphery. So on the kind of superficial surface of whatever the cartilage is. Those cartilage produce matrix and they become chondrocytes in the lacunae. And as a result, you get a larger piece of cartilage. And the newest cartilage from this type of growth is formed on the outer edges of the new cartilage. Again, just a couple images here. So lacuna, just kind of an empty space. You have this chondrocyte in the middle, and then it's building matrix around it. Some mitosis happening, and you have two chondroblasts within that lacuna. They then develop and form, and eventually, as that matrix is formed around them, they become two cells. Appositional growth, again, same idea. Now we're looking more at that surface, that perichondrium. You have some mesenchymal cells out here growing, and you have new cartilage happening within. Some mitosis, more matrix being produced, and so you have the new matrix out here, and the bone grows from the periphery, the outside surface. Bones of the well, let's transition to bone. I got ahead of myself. Bones of the skeleton are complex and dynamic organs containing all four of our major tissue types: epithelial tissue, connective tissue, muscle tissue, and nervous tissue. So when we say dynamic organs, and oftentimes we think of bone as just kind of a static structure that doesn't really do anything. But bone is constantly building and degrading and repairing and changing throughout our lives. So it's composed primarily of bone connective tissue. The extracellular matrix around bone is mostly due to calcification. And that's why having lots of calcium in our diet is really, really essential. The functions of bone and bone connective tissue, it supports and protects the more delicate organs. We have an internal skeleton, us as mammals do. And so it provides that internal support. It also protects our delicate organs. Think of your skull, the bones of your skull. Think of your ribs and your rib cage. Provides that protection. It also allows for movement. So we have muscle attached to the outsides of our bones. And it is tendons that attach muscle to bone. And those muscles, and remember, muscle tissue is designed to contract and produce movement. So when it contracts, it can move our skeletal bones. And then hemopoiesis is the development and production of red bone marrow, and that produces red blood cells. And then bones are also used to store mineral and energy reserves. That's one of the functions that is often forgotten about bones, is that they are just an energy and mineral storage zone. So they store calcium, they store phosphate. Calcium is necessary for muscle contraction. Phosphate is necessary for energy in the form of ATP, adenosine triphosphate. And so both of those can be stored in the bone and used when the body is low on calcium or phosphate. Lipids or fats and are long-term energy. Those are stored within the bone in the yellow bone marrow. And if you get a chance to open up a bone, you'll notice that the inner part is kind of greasy, and that's that lipid within there. Bones are classified by kind of their shape and look. And so we have four major classifications. The long bones. This is like your stereotypical dog bone. It's got these wider ends. And then you have the short bones, which aren't all necessarily short, but they're just kind of mostly, I would say, shaped like rocks, something that you might find on the ground. If you didn't know it was a bone, you might think it was a rock. Flat bones typically are more flat. They can be rounded, like in the skull. And then you have irregular bones, like our vertebrae, which have just kind of all sorts of interesting shapes to them. So what I recommend doing is taking your bones, and the first thing that you should do is try to classify them in piles by these classifications: long bones, short bones, flat bones, irregular bones. Note that long bones can be awfully short, like in the case of your fingertips and tips of your toes. Short bones can actually be quite large, like in your heel. But I think that's a good exercise to start with as you begin learning bones. And that's where we're going to end today. Hopefully that was a good introduction, hopefully helpful, and we will see you next time.